Hi, my name is Alexander Insul Anatoni. My student number 2025891898. Now, today we will explore what redox reactions are, how, how they work, and why they matter in life. Now, let us see redox reaction in real life application. First, water treatment. It uses for Re- remove, remove water polluted. Second, metal extraction. For example, extracting iron from iron ore. Lastly, burning fuel combustion, like burning petrol, gas, or coal that involve redox reaction. Now, let's talk about redox definition. A redox reaction is a chemical reaction involving both reduction and oxidation. It occurs when electrons are transferred between substances. Redox reaction can be defined in four key ways. First, transfer of oxygen, transfer of electron, third, transfer of hydrogen, and change in oxidation number. Now, I will explain about transfer of oxygen. In reduction reaction, it's involving oxygen. Oxidation is gain oxygen, but reduction is lose oxygen. For example, iron lose oxidation that called reduction, while the carbon monoxide gain oxygen is called oxidation. Second, transfer of electron. Electron transfer is another way to define the redox. Oxidation is the loss of electron, but reduction is the gain of electron. This is especially important in the electrochemistry and metal displacement reaction. Now I will explain the transfer of hydrogen. In hydrogen-based redox reaction, oxidation is the loss of hydrogen, while reduction is the gain of hydrogen. For example, nitrogen gain hydrogen is called reduction, but hydrogen is oxidized. Now for chain of oxidation number. Oxidation number help track electron movement. Oxidation is an increase of oxidation number. Reduction is a decrease in oxidation number. For example, Cl goes from 0 to minus 1. It's called reduction. But I goes from -1 to 0. That's called oxidation.
Next, we will learn about oxidation number of element in compound. Oxidation number is the number of charge the atom would have a molecule, which is ionic compound, if the electron is transferred completely. Let's look at the example that I have provided. First, for iron, like zinc 2 plus and O2 minus, the oxidation number is the same as the charge. For pure element, like neon and helium, the oxidation number is always zero. We will now learn the rules to determine oxidation number. First, we will learn the general rule. Number 1, any element in its natural form has oxidation number 0. Number 2, for iron, the oxidation number is equal the charge. Number 3, the sum of oxidation number equals the overall charges. Rules for specific atom or periodic table group is based on this table given here. For group 1, the oxidation number is +1, group 2 +2, group 13 is +3, group 14 is +4, group 15 is -3, group 16 is -2, group 17 is -1, and lastly group 18 is 0. Therefore, based on this table given, we can learn or know the ion charge of its element. We will now determine the oxidation number based on the example given. Example 1. Find the oxidation number of S in SO4 2 minus. First, we need to rewrite the SO4 2 minus equals to negative 2 based on its charge. So, S plus with 4 times with negative 2 equals to negative 2. 4 times with negative 2 equals to negative 8. So, when we move the negative 8 to the left side, it will become positive. Then we can calculate the negative 2 plus 8 equals to positive 6. Therefore, the oxidation number for S is plus 6. For example 2, find the oxidation number of C in C2O4 2 minus. The same thing we did from example 1. We need to rewrite the C2O4 2 minus equals to negative 2. Then, since there are two atoms of carbon, we can just write 2C plus 4 times with negative 2 equals to negative 2. 4 times with negative 2 equals to 8, and when it's moved to the left side, it becomes positive. So it will become 2C equals to negative 2 plus 8. Negative 2 plus 8 equals to positive 6. So 2 atoms of carbon equals to plus 6. We can divide the two carbons into 1. So plus 6 divided with 2 equals to plus 3. Therefore, the oxidation number of C is plus 3.
This slide explains the difference between reducing agent and oxidizing agent in redox reaction. Reducing agent is a substance that loses electrons because it donates electron to other substance, so it oxidizes itself. While oxidizing agents is a substance that gains electron. Since it accepts electron from others, so it's reduced. In a simple terms, reducing agents give electrons, while oxidizing agents accept electron. This slide shows steps for identify the substance. If the substance oxidizing, it means it lose electron, so it's identified as reducing agent. If the substance reduce, it means it gains electron, so it's identified as oxidizing agent. This is example how to identify the oxidizing in reducing agent. In the left, Al equals to 0, while Al in Al2SO4 3 equals to positive 3. Al goes from 0 to positive 3, which is lose electrons, so it's reducing agent. In H, in 3H2SO4 equals to positive 1, while H in 3H2 equals to 0. H goes from positive 1 to 0, which is gain electron. So it's oxidizing agent. So this is the other example. Zinc in the left equals to 0, while zinc in ZnSO4 equals to 2 plus. Zinc goes from 0 to 2 plus, which is lose electron, so it's reducing agent. In CuSO4 equals to 2 plus, while the other Cu is 0. CuSO4 goes from 2 plus to 0, which is gain electron, so it's oxidizing agent.
Some equation for oxidation reduction reaction can be easily balanced by inspection. However, it is often easier to balance the oxidation reduction reactions by the half reaction method. This method is based on the principle that all the electron loss is an oxidation half reaction must be gained in a reduction half reaction?
Secondly, why do we need to use the half reaction method? It helps us with separating oxidation and reducing reduction clearly. Second, tracks electron transfer accurately. The last one, ensure both atoms and charge are balanced. Balancing redox reaction acidic medium. Firstly, split the reaction into oxidation and reduction half reaction. Second, balance atoms and charges in each half reaction. Use H2O for O, H plus for H, E for charges. Thirdly, multiply half reaction so the number of electrons lost equals to electrons gained. Fourth, add half reaction together and cancel identical species on both sides. Lastly, check check that all atoms and total charges are balanced.